All right, now this is the data for part 1 of the Simple Harmonic Motion Lab. As you can see, I put a little twist tie in there because it's just a little easier to read. Put the meter stick on there because we need the 0 mark when the 50 gram is on there. We chose 50 grams for this spring because we see that it's beginning to oscillate. Put enough weight on there, put enough mass on there in order to get it to start oscillating. Your spring might be a little different, so whatever you do, put enough on there where it starts wiggling a little bit, and then mark down with the 0. So 42 is going to be our special number. It is the meaning or the answer to the question, what's the meaning of life? All right, so now we put 20 on there, and we take another reading. We are not counting to 50, so really we're saying there's only 20 on there. Now there's 40 grams. $60 grams. $80 grams. Wait for that to stop wiggling before you read it.
When you start off with the mass hanger, you just want to make sure that, as Mr. Retenzi said, there is some wiggle on it. Otherwise, you might have to stretch the spring out ever so slightly.
Or not too much, otherwise you end up at a hardware store buying your own spring.
Please avoid stretching the spring if you at all can do so.
Tell me how many times I've done that. That was right now with 1, 2, 3, 4, 5. That's 100 grams on there. And now we're at 120. $120. $140. $160. And let's go to 180 extra mass. All right, this is part 2 of the Simple Harmonic Lab data taking. We have ourselves a stopwatch, and then we have an oscillating mass up and down. Remember that you start your stopwatch and you count in your mind 10 oscillations, so that when you start your stopwatch, remember, stopwatch is saying 0, you say 0 in your mind. Now we only have 60 grams on here for trial number 1, so it's probably going to be the most difficult part of your lab is to do the smaller masses, because obviously they're oscillating up and down much quicker. And again, like Mr. Carney reminded you before, the amplitude doesn't matter, but don't smack it to the top. So this is going to have to be a fairly small amplitude for it not to bottom up. I don't know what the word would be for it to jam up to the top. Clank at the top. So here goes. I'm going to start the stopwatch.
And we're gonna let 20 oscillations go, and you can stop it at 10 oscillations or 15 or 20.
Good point. So you may not be starting at 0 on the watch, but in your mind you're going to count 10 oscillations, complete oscillations. So in your mind count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then find out what the clock said after 10 oscillations. Here we go. Remember, we have 60 grams on there. That 50 gram mass plus 10 more. The 50 plus 10, it really is 60 now. 60 grams of inertia. All right. Trial number 2, we're going to add 60 more grams. So altogether, we have 60 grams plus the other 60. We now have 120 grams on there. See if you can make a prediction on what the period would be. Remember, the period is 1/10 of 10 oscillations. So we just do this. You can start it anytime you want. Start the clock and take data. I'm going to start your counting at 0. So you go 0, 1, 2, 3, 4. Okay, hopefully that'll give you enough. If we add another 60, we have trial 3. Altogether, we'll have now 180 grams hanging on this mass. Hanger plus another 130, 180. So remember, amplitude doesn't matter if the period's the same, if the wiggle is like this or the wiggle is like this. So to help you read it a little bit, we can have the amplitude a little bit bigger this time because we won't do that clank when we get to the top, and take data. Again, you can use your own stopwatch and just watch the video if you don't like this one. All right, hopefully that's enough to give you. All right, trial 4 for part 2 of the Simple Harmonic Lab is to add another 60 on there. So now we have a total of 120. Mr. Carney and I have been looking through the kit trying to figure out how it says 250 on the Made in China kit. We're only getting 145, but that has nothing to do with the lab. We just wanted to share that with you. So here goes. See, look at that, look at that. Period's nice and easy to count now. So start anytime you want.
If you do use your own stopwatch, just be mindful if there's any glitches in the video being received on your computer that you're going to have to re-watch it. You have to have good internet connection if you're going to use your own stopwatch.
Alright, hopefully that will give you enough data. Hi folks, this is the data taking section of the Simple Harmonic Lab Part 3, the pendulum. We are now going to just vary the length. What's the length of a pendulum? It's from the pivot point to surprise the center of mass of the mass. Now if you recall from last semester, whenever you took the equivalent of Physics 118, the center of mass for an object is where all the mass acts as if it is. You have to take some calculus to prove it, but it's the spot where it's the balance point. If I have a meter stick, the center of mass is wherever it would just balance there. So for this meter stick, it's 50.5 centimeters. I don't know why, but yeah, what can you say? It's from a different country. So if I take this off, I can't measure from the bottom because that's not the center of mass. I don't know where the center of mass is. So the best I can get is find out where this would balance. And son of a gun, it balances real close to the top. So if you choose, and you don't have to do this, to use this hanger as the center of mass, you can use a ball, and that's easy. It's the center of the ball. Okay? If you have a particular shape, you have to figure out the center of mass of that shape, and then the length of the pendulum is from the center of mass to the pivot point. So what we're going to do from now on is measure from the top of the mass, because it looks like the top of the mass. This mass here is equal, believe it or not, to the mass that's hanging, so, or the mass on the bottom. So it looks like center of mass, we're going to measure from the top of the mass. That's just for the hanger that comes with your kit. Again, if you choose to do your own pendulum bob out of some other object in your house, now you understand that it's from the center of mass to the pivot point. That's the length of our pendulum. So, Mr. Carney and I already pre-measured, hopefully, the first trial to be 1 meter long. So the string is 1 meter long, and we're going to take the data with a stopwatch and measure how long it takes to go through a complete cycle. Now, our recommendation always is to cut down on your reaction time by measuring 10 oscillations, then dividing by 10 to get the average period of 1. It just comes out with better data that way. So, I can start this at any time. Remember, you start with the number 0 in your head. You go 0, 1, 2, and you start counting from 0. All right? This is a good position, Mr. Carney?
A little higher.
A little higher? Would it be better if I was like there?
Yep, that's good.
Okay. So we're going to start this, and then you guys can start at any time. You can pause the video and see what the clock said when it gets to the end, and then do 10 oscillations. Here we go. Feeling sleepy. Sleepy. Okay, hopefully you have 10 oscillations. You're going to divide by 10. If you miss it, you can go back and watch this video over again and pause and see what it was for 10 oscillations.
Of course, you could use 15 or 20 oscillations as well.
Good, thank you. It doesn't really matter how many as long as you divide by that many, and that you start at 0 instead of 1. Alright, that should be enough for you. That would be 100 centimeters.
Now you're going to shorten that up to 90.
Right. So let's show you how to shorten this up to 90, and then we'll start pausing the video from then on so that you're not sitting there watching us measure. Now we got this at 90 centimeters. From the center of mass of the meter stick to the top is now 90 centimeters. Alright? And clear this. Wiggle it. And interesting, as long as the amplitudes are really tiny, don't go crazy over here like this. Keep the amplitudes relatively small, and you should get very good data, because then we can do that approximation for amplitude not mattering. And here you go. Is this a pretty good position? Let's make sure it's going sideways. And if you don't use your own stopwatch, you use ours. Feel free to start at any time and get 10 oscillations. Alright, here's the data for 80 centimeters. Keep in mind that you're changing that to meters, so 0.8 meters. Begin anytime. Count 10 oscillations. Okay. All right, now we have 70 centimeters of the length of the pendulum from the mass center to the pivot point is 70 centimeters, 0.7 meters, and begin 10 oscillations. hopefully you have 10. All right, now we have 60 or 0.6 meters, 60 centimeters, 0.6 meters, and begin timing whenever. It'd be really nice if you looked at your data and started making a prediction if the length, the next one that we're going to do is 0.5. See if the length being half, can you predict what the new period would be? Alright, should be done. Okay, now we have 0.5 meters, 50 centimeters. The length of the pendulum is now 50. And again, we want you to start thinking about, we are now at half the length that it was when it was 1 whole meter. It'd be great if you could just take a prediction on what you think the period would be now compared to what the period was when the length of the pendulum was 1 meter. Is it exactly half, or is there some other kind of relationship? Alright, begin timing anytime. Alright, this should give you 10 oscillations. Write down that, divide by 10, you get the period average for 0.5 meters. Hello, it's 40 centimeters now, or 0.4 meters. And start the clock. Record any time, 10 oscillations. Alright, that should give it to you. Alright, this is 0.3 meters, 0.3 or 30 centimeters. And begin. Should be enough. Alright, now we have 0.2 meters, 20 centimeters from the center of mass to the pivot point. Begin timing 10 oscillations. Alright, that should give you plenty. Alright, this is now 0.1 meters or 10 centimeters. Keep in mind that this has more error. The ones with the shorter lengths have more error because we made it an approximation on where the center of mass was. So that's not going to be a factor when you have 100 centimeters, but this is going to be more of a factor. So if I was going to graph something, I would probably take these data points a little less seriously than the ones with the longer ones. Just kind of a little bit more of a skew there. Alright, so here goes, 10 oscillations. Okay, now, before we end this, keep in mind that we are going to graph the period on the y-axis and the length of string on the x-axis to see that relationship. If that relationship doesn't make you happy, we're also going to do period squared versus the length and see whether or not the period depends on the length or the period squared depends on the length. What would the slope of the line of whatever one is linear give you? Things like that. It'll all be in your lab write-up.